Intro Algebra Lesson 1-1B, continuing what we were speaking about before. If we were to then look at our units, we were talking before about different formulas. We talked about simple interest formula. You have distance equals rate times time, and sometimes in those formulas you have units that you have to deal with, and it's always good to think about your units, which we would call unit analysis. Unit analysis helps us to determine the units for your answer. If the same units are in the numerator, at the same time they're in the denominator, then they will cancel each other out. Alright, so here's an example, and I'll elaborate on this example. Say we started off and we had time is equal to distance divided by rate, which is T equals D over R. That's one of our main formulas for distance. Time equals distance divided by rate. If you were going, or if you traveled 100 miles at 50 miles per hour, 100 divided by 50 would give you 2. It would take 2 hours for you to travel that distance at that speed, at that rate. Now, distance is a measurement in miles, so I have MI for miles, and rate is always something per some sort of time, so miles per hour. Now, because this is division, instead of taking miles and dividing by this fraction, that's the same as taking miles, and if you want, you could write it over 1, because you could keep it as a fraction, miles over 1. Instead of dividing by this fraction, you can multiply by its reciprocal. So this miles over hours gets flipped and becomes hours over miles. Now, numerator and denominator are the same. Anytime the numerator and the denominator are the same, they will cancel out, which leaves us with h over 1, which is h for hours. So this is unit analysis, making sure you did it correctly. If I had messed up, and instead of flipping by the reciprocal, or multiplying by the reciprocal, and flipping this fraction over, and I said, oh, I want to take miles over 1, and I multiply that by miles over hours, you'll notice nothing is the same on the top and the bottom to cancel out, because miles are on top. And if I tried to multiply this through, I would end up with miles squared over hours, which is not a very good unit of time. It tells me I must have made some sort of mistake. So unit analysis actually helps us when we set problems up, so that as we're going through, if we know we should be canceling out the miles so that time is left, then it will help us out so that hours are left. It helps us arrange problems in the correct way. If I put some actual values to this, we could say that time, t, is equal to, and I used the numbers I had before, 100 miles divided by the rate of 50 miles per hour. Now, I know that you can take 100 and divide by 50 fairly easily, but let's make sure that we actually can do it like we did over here. This is actually a fraction, 50 miles over hours. We could say that instead, 100 miles over 1, basically just taking this numerator and writing it as its own fraction, and instead of dividing, which I'll write it out as division like this, dividing by 50, because that's what I'm dividing by, 50 miles over hours, and that's miles over hours, miles over hours. I guess you could add a little I in there for you. Instead of dividing, if we want to change division into a multiplication problem, you always flip the second fraction. Never flip the first fraction. So now it becomes 100 miles over 1 multiplied by hours over 50 miles. At this point, we can do all kinds of canceling. We can cross simplify. 50 goes into itself once and into 100 twice, as well as the miles cancel out with miles. Therefore, all that's left is 2 hours over 1. And anything over 1 is just the anything. So we end up with 2 hours, which is exactly what we thought it should be if we were traveling 100 miles at 50 miles an hour. It would take us 2 hours to get there. So it works. Alright? A little bit about our problem-solving strategies here. We got a verbal model. Anytime we take a verbal model, verbal are words, We're translating real-life word problems into mathematics. If I had to pinpoint something that was very difficult for a lot of students, I would say translating real-life word problems into math pretty much sums it up. You got to really be careful with this. This is something that requires a lot of practice. All right, so I'm going to try to set up some things here to help you out. We'll try this problem out with a verbal model. You estimate. Now that means it's not going to be exact. It's an estimate. It will you estimate, I probably should say, you will drive about 55 miles per hour to your grandmother's house. The distance is 220 miles to her house. How long will it take to get there? So we know the speed. We know the rate. We know the distance. D. What we don't know is the time. Back here, we said that time was distance divided by rate. So we should be able to use that exact same formula. So we're translating the real-world problem into math. We're saying, okay, this is a time equals distance divided by rate problem. It's the same idea. So first thing, step number 1, we want to write a verbal model. Verbal model is something in words. So here's the problem in words. Time equals distance over rate. I didn't make up that formula. It's a formula that's been given. It makes sense that if we went 100 miles at 50 miles an hour, it would take us 2 hours to get there, like we saw in the last problem. So this is a good verbal model. From the verbal model stage, we'll create labels. There's basically 3 parts of this problem. Out of those 3 parts, we know 2. One of them we don't. The one that we don't, we use the variable t. T for time. It's one we don't know. We know the distance is 220 miles. We know the rate is 55, which means we'll be able to use substitution and plug those values in. So we start at the verbal model, problem in words. We assign labels. Labels just means figure out what we can plug in and what we don't gets variables. From there, we have the algebraic model. Verbal model in words, labels, figuring out what we know and what we don't, and substituting it in. Notice the 220 miles is in distance, and the 55 miles per hour is the rate. What we don't know, t for time, is right here. Then we have our answer of 4. If we take 220 and divide it by 55, we will end up with 4 hours. Remember, this line means division. So once again, start with words, replace the words with what you know, stuff that you don't know gets a variable, and then go ahead and simplify the math as far as you can, in this case, 4 hours.